Hey everyone, welcome back to my podcast, Anatomy and Physiology Bit by Bit. This is your host, Dr. Steve Sullivan, coming to you from just outside of Philadelphia, where I teach anatomy and physiology at Bucks County Community College. In today's episode, we're going to talk about muscles. We've finally reached our muscle unit, and we're going to open up with this episode, just basically talking about different kinds of muscle tissue, what muscle tissue is, some of the features of muscle tissue, its properties and characteristics, and then we'll also talk about the different functions of muscle. And then in subsequent episodes, we'll get into some more details about how muscles work, how they do what they do. So we are looking pretty good here in the Northeast in terms of COVID. We have yellow phase in Pennsylvania. Looks like we're going green pretty soon, which is opening things up, but hopefully people are remaining safe and continue to use some common sense tactics to limit the spread of the coronavirus. So I hope that you are all doing well. I got a really interesting question from a listener in Georgia, and the question was about stem cells and how stem cells actually become cells that you implant them to. So I think this is basically about using stem cells as a therapy. So if there's an injured area, like an injured spinal cord, implanting stem cells so they become the cells that they're trying to replace. And the way that happens is through a process called induction. So you have the cells in the area that are already existing differentiated adult cells, meaning that they're specialized in what they do and what they look like. They induce the stem cells that are near them to actually develop or differentiate into the surrounding cells. And that is called induction. It's about stimulating specific parts of the DNA to start synthesizing proteins so that the cell develops into what it's supposed to develop into. So thank you for that question, and thank you for being a loyal listener. I know that I haven't been putting these episodes out as quickly as I would like, and I appreciate your patience. So hopefully these are getting to you in time to learn something good and to help you with your A&P course. Right now we are in the beginning of the summer sessions, so when I'm recording this right now, it's June 18th, 2020. And a lot of people are in their summer session courses or about to start a summer session course, and hopefully this is helping you do that. So without any further delay, why don't we get into muscle tissue? Our bodies have over 700 muscles distributed about as far and wide as you can imagine. Almost everywhere you can think of in your body, there's muscle there. There are 3 different types of muscle tissue. You're probably familiar with skeletal muscle, which we usually see attached to bones so they can move. Then there's smooth muscle. Smooth muscle is found in the walls of many hollow internal organs, like the digestive tract and blood vessels. Smooth muscle helps those organs propel their contents or change their diameter. And finally, our heart is made of cardiac muscle, which works to pump blood into the arteries. The prefix myo refers to muscle, and just like most tissues, all muscle tissue consists of cells. These cells are called myocytes, and when at rest, they're typically longer than they are wide. The 3 muscle tissue types have very different functions, but they all share a set of physical properties. The first property is contractility. This means the muscle cell can become shorter than its resting length. Becoming shorter is called contraction, and it's how muscle tissue moves bones and other materials. Number 2 is excitability, which means the cell will respond to a stimulus. This by far is not unique to muscle cells, but it's their response to changes in the membrane's electrical potential that stimulates them to contract. I like to refer to them as electrically excitable. Excitability is great, but what really gets the myocytes going is their ability to conduct electrical signals along their plasma membrane. This is called conductivity, and it makes sure that the entire muscle contracts by exciting segment after segment after segment. It's no secret that muscles can stretch. You've probably stretched your own muscles. That's called extensibility. Unlike most cells, myocytes have the ability to extend beyond their resting length without being injured. The fully extended length of a muscle can actually be 3 times what its fully contracted length is. You may also have noticed that muscles snap back a bit after you stretch them. That's elasticity, which means they not only have the ability to extend, but afterward they return to their resting length without having been damaged or permanently stretched out. While all 3 muscle tissue types possess these characteristics, there are also some important differences between them. For one, skeletal muscle is voluntary. This means that under normal circumstances, a person decides and controls when and when not to contract skeletal muscles. If you want to pick up a cup of coffee, you have to generate the nerve signals in your brain's outermost region called the neocortex to initiate the contraction of the necessary muscles. That's voluntary. However, some skeletal muscles seemingly contract without your say-so. Take breathing or blinking, for example. Those actions are achieved with skeletal muscles, but you don't have to initiate them. You can stop them if you wish, but you don't have to remember to breathe or blink. This is called automatic. Involuntary means something entirely different. Cardiac and smooth muscle contractions are involuntary, meaning they're controlled by lower regions of the brain or spinal cord. So you don't have to worry about remembering to pump blood into your arteries or propel food through your digestive tract. And you can't stop it either. It's involuntary. Cardiac muscle is only found in the heart, and its function is pretty straightforward. It pumps blood into the arteries. This is a more appropriate discussion when we cover the cardiovascular system. But in a nutshell, cardiac muscle surrounds the cavities of the heart, and when the myocytes contract, the spaces inside the cavities get smaller and force their contents out. This moves blood into the arteries so it can get to the rest of our tissues. Smooth muscle can be found in several organs and structures, and its functions are dependent upon which one. So we'll go into more detail as we get to each of these systems, but take a more general look here. In the cardiovascular system, smooth muscle contraction changes the diameter of blood vessels, regulating blood flow and pressure. In the respiratory system, contraction of smooth muscle changes the diameter of certain regions of the airway, regulating the flow of air into and out of our lungs. While in the digestive, urinary, and female reproductive systems, the contraction of smooth muscle is utilized to propel the contents of a lumen or cavity distally through a tract. Those contents may be what's left of the food and water we consumed, urine on its way out of the body, or a fetus on its way to becoming a newborn. Skeletal muscles are the muscles you probably know some of the names of, like the trapezius or pectoral muscles. There are several functions of skeletal muscles, but you're probably most familiar with the way they contribute to moving your body. Function 1. Movement. Many skeletal muscles attach to bones and cross joints, so when they contract or become shorter, the bones move at those joints. So moving the skeleton is one of its functions. The contraction of the muscle tissue generates a force that opposes the force holding the bone where it rests. If the muscle's force overcomes the opposing force, the bone moves. Sometimes that force is simply gravity and the weight of a body region being moved. Sometimes it's a weighted object, like a cup of coffee or a dumbbell. And sometimes skeletal muscles contract without moving the bones. Not all skeletal muscles are attached to bones. Sometimes they're attached to soft tissues, and the movement they create doesn't move the skeleton at all. For instance, the diaphragm is a skeletal muscle that changes the dimensions of the thoracic cavity so we can inhale. Many of the muscles of facial expression attach to other muscles, and when they contract, the expression on our face changes without moving any bones. Some skeletal muscles are circular in shape, with a hole in the middle like a donut. These muscles are called sphincters, and when they contract, the hole gets smaller and may even close completely. One example is the circular orbicularis oculi muscle that surrounds the eye. When it contracts, your eye closes. Function 2. Maintaining posture. Even when the muscles do attach to bones, it doesn't mean their contraction will move the bones. When we're standing upright, we're opposing the force of gravity to remain that way. So muscles have to contract to keep our skeleton from collapsing to the ground, maintaining our posture. Function 3. Physical support and protection. The abdominal cavity contains some vital organs, but doesn't have the protection of bones like the thoracic cavity does. Rather, multiple layers of muscles and fascia keep the contents of the abdominopelvic cavity contained, supporting them in their location and protecting them from outside forces. Function 4. Blood sugar regulation. Contraction of muscles is a lot of work, and it requires a lot of energy. This need for energy means muscles synthesize a lot of ATP and therefore absorb, store, and utilize much of the body's glucose. Muscle tissue gets its glucose from the blood plasma, meaning it plays a large role in keeping the glucose concentration in the blood from getting too high. Function 5. Regulating the passage of materials from one location to another. Sphincters throughout the digestive tract contract and relax, changing the diameter of their openings. This regulates when food in the esophagus becomes food in the stomach, when stomach contents move into the small intestine, and when small intestine contents become large intestine contents. These are just a few examples. Circular skeletal muscles like these also regulate urine flow and how much light reaches the retinas of your eyes. Function 6. Body heat production. As I said earlier, work requires energy and muscle contraction is work. However, not all of the energy consumed for muscle contraction is used for the actual contraction. The ratio of the work performed to the total energy expended is known as efficiency. Since energy can't be created or destroyed, the amount that isn't used for contraction is released as heat. Think of light bulbs. The less efficient the bulb, like a traditional incandescent bulb, the hotter it gets. More efficient fluorescent bulbs don't get as hot. That's because more of the electricity is being spent on generating light and less is lost as heat. Since our body temperature needs to be much warmer than the usual temperature of the atmosphere, the heat lost by muscle is used to keep the body warm. Most skeletal muscles attach to the bones of the skeleton at areas we call skeletal attachments. Some of those attachments are direct, meaning the muscle tissue itself directly attaches to the bone. Others are called indirect attachments. These muscles attach to the bones via collections of dense, regular connective tissue called tendons. Most tendons are arranged like a rope or a cord, but some are a broad sheet called an aponeurosis. When skeletal muscles that are attached to bones contract, the bones they are attached to typically move at the joint the muscle crosses. This movement is referred to as the muscle's action. Not all skeletal muscle contractions move bones, but for the purpose of this discussion, we'll focus on it this way. Each skeletal attachment is traditionally known as either an origin or an insertion, the origin being the more stable attachment, and the insertion being the more mobile attachment site. These terms can be confusing because sometimes muscles cross more than one joint or have more than one action, and one attachment site may be the more mobile site for one action and the more stable for another. Therefore, many of the authorities for anatomical terminology are beginning to eliminate these terms. That doesn't mean you won't still see them. It's going to take some time before practitioners and academics stop using the traditional terminology. Modifying each skeletal attachment by using directional terms like medial and lateral, or proximal and distal, for example, may prove more anatomically descriptive for these attachment sites. The fleshy part of the muscle tissue between those skeletal attachments is called the muscle belly. Just like most tissues, muscles need a blood supply. The blood vessels bring nutrients, water, hormones, electrolytes, and a long list of needed materials to the tissue, while it also carries away waste products.
You buy a pair of socks, that's 2 socks. You buy a pair of Bombas socks, that's 4 socks. Because one purchased is one donated. Socks are the #1 most requested clothing item in homeless shelters. So when you buy a pair of super comfortable Bombas socks, you're also donating a pair. Bombas customers have powered over 150 million donations. So Bombas would like to thank you 150 million times. But we only have like 30 seconds. Go to bombas.com and use code AUDIO for 20% off your first purchase. That's BOMBAS.com and use code AUDIO at checkout.
Muscles also need an innervation. The word innervate means to supply with nerves. Muscle tissue is electrically excitable, and skeletal muscles are voluntary. So it takes a motor neuron to help generate that electrical stimulus provoking the contraction of a skeletal muscle. If you look at a cross-section of the muscle belly of a skeletal muscle, you'll see that it looks like a bundle of tissues. But in reality, it's more like a bundle of bundles, all wrapped in their own connective tissues. Let me explain by starting with the smallest parts of skeletal muscle tissue. Skeletal muscle cells, or myocytes, are also known as muscle fibers, or myofibers, because they can be very long and thin. Inside each of those myofibers is a bundle of myofibrils wrapped up by the myocyte's plasma membrane, which is called the sarcolemma. Fibril means a smaller version of a fiber. Each myofibril consists of a bundle of myofilaments, which are the proteins that do the work resulting in a muscle contraction. So already we can see that a muscle fiber is a bundle of myofibrils, and a myofibril is a bundle of myofilaments. If we step back a bit, we'll see that the myofibers are separated from each other by a connective tissue called endomysium. Several myofibers are bundled together by another connective tissue called perimysium. This bundle is called a fascicle. Fascicles are not microscopic. You can see their arrangement when you cut into a steak or a pork chop. And finally, thousands of fascicles are bound together by a layer of connective tissue called the epimysium, and that makes up the muscle belly, the largest of the bundles. Still, another sheet of connective tissue called fascia separates one muscle belly from another so they don't stick together when they move. Sometimes fascia separates muscles from non-muscle tissues. And sometimes it's used to group muscles together in a regional compartment, separate from other groups, like in the lower leg or the forearm. Okay, so that's the basics of what muscle tissue is, what are its characteristics, what are its functions, and all that good stuff. So hopefully that you've gotten something out of that, and you can use that to help you understand the basics of muscle tissue. In the next episode, we will talk about some more specifics as to how the muscle tissue performs all these functions. So hopefully you'll tune in for that episode, and I will have it posted for you as quickly as I can. Good luck, be well, and I'll talk to you next time. Hey everyone, don't forget to check out my YouTube channel, Student Help for AP. Student Help, the number 4, AP. There's a lot of tutor videos on there that I think could be really helpful. I also have an Instagram account and a Twitter feed with the same name. Anatomy and Physiology Bit by Bit is a production of Minus 55 Media, with a special thanks to Bucks County Community College, McGraw-Hill Higher Education, and my family.